Building on that, now we turn to our next session, turning physical AI into serviceable, scalable systems. Always GBPS 60 GHZ link UC60 is a topic that highlights the power of turning complex technologies into practical solutions ready for real world deployment. Understanding how advanced systems can deliver consistent, high speed performances is critical for organizations looking to innovate and expand efficiently. In this section, our speaker will walk us through the design and implementation of sophisticated platforms that go beyond theory, showing us how to use these systems become functional, reliable, and scalable. Please join me in welcoming Young Dong Kim, CEO of Aniquan, hopefully I'm saying that correctly, to the stage to share his expertise and experiences. Let's give him a warm round of applause. Let's welcome him up to the stage. Microphone is all set up.
Thank you. Good morning, everyone. It's not morning now, and a little bit delayed, and it's almost noon, so good noon would be appropriate, right? So I'm from Korea, and our company is a unicorn, and we developed communication semiconductor chip with the 60 gigahertz, and this could be not funnier than previous content, but it this kind of content would be something that you might never heard of before, or you might never thought of before. So and please kindly allow me, because I'm pure Korean and definitely South, not North, South Korean, and my English is not so good. So please, I hope your generosity to understand. So I'm gonna talk about how we can scale physical AI and also how to make it serviceable. So when it comes to physical AI, we normally have a two physical AI, how can I say, hardwares. First one is a humanoid or electronic vehicle, self-driving cars, and also these days, AI space data center is arising these days. So yeah, let me go directly. So we only have 15 minutes, but let me go quickly before it's just before lunch. So main subject is two things. First one is a why AI data center in space. Why does it need it in AI in the space? First one is a space energy. Space offers abundant solar energy without day-night interruption or weather loss. So Testarian data center on Earth requires huge new power plant or grid energy service, and there are a bunch of NIMBY not in my area. So energy in space is abundant and not limited. So in terms of energy, AI data center in space is kind of in terms of capex or opex, it's more efficient and effective. And it also bypass Earth's growing bottleneck, like as I mentioned before, land grant capacity or permits or local opposition like a NIMBY. And in terms of scale, AI demand grow exponentially. Space opens a path to infrastructure at a much large physical scale. So it turns AI infrastructure from a local real estate problem into a global orbital platform. And also, uh, next subject is much funnier. And why self-driving car does AI inference? Uh, when you park or charging your car, the car itself is idle. And these days, car, self-driving car or self-driving electronic vehicle, it already contains very supercomputer, like a 2000 tops tera operation per second, or much better computer than you have. It's like almost NVIDIA, Blackwell, or yeah, those kind of server level. Then what if we can rent or lend our car or compute power to grid distributed data center? Then we can make money. For example, when we think about 2000 tops, which is already inside of the car, when we borrow those kind of computing power from Google Cloud or Amazon Web Service, we have to pay around um, 5 to almost 10 US dollar per hour. Then we already have those kind of computing power in our car. Then it when we parked or charging, when we can communicate together, then when we rent our computing power to our grid data center or virtual data center, then efficiency would be maybe 50% or less than that. But when we think about two or couple of dollars that we can make when we park toward charging, then we multiply by 12 hour and 30 days and 12 month, then those money will be around 10K USD per year. So this is not a small money. So this could be this money could be how can I say appear because car is already idle when we park toward charging. We can use those idle time, and also AI computing demand is on the peak. And also we like Elon or Jensen Huang, they always mention that AI computing power should go thousand times higher or order of magnitude higher. That means the car should be worked as a computer for the grid computing. Then we can make money, car owners. So instead of sitting idle while charging or parked, the vehicle can generate computing time. In other words, a car owner can make money. And also it can expand AI infrastructure without building the same amount of new data center capacity. And also this kind of when parked or charging, it can be connected with the server or backbone. The one of the problem of the self-driving is the edge case training or model update. So same connection can upload edge case driving data or download updated models. So it can be more safe self-driving and also cheaper to implement safer self-driving. So this is our chipset. We call UC60 because we leverage 60 gigahertz, very high frequency. So I'm not sure if you can see this. Yeah, this black one. This is our chipset, very small. So smaller than normal connectors, physical connectors. Uh, so far, when we link some data source to data sync, we have to connect the cable or connector physically. It could be copper or it could be fiber optic. But now we make it even we make it chipset wireless by 60 gigahertz. So we can solve the problem by the physical contacting wear and tear problem or frequently uh, plugging out, there could be a mechanical problem, and we can dealing with that because we don't need the physical contact. I'm a CEO and co-founder of the Unicorn, which is located in Korea and Tokyo and Shenzhen and also San Diego. And we raised fund around 100 million USD so far for 4 years and supported by Korean government. And actually, I'm honored and privileged to be here, Tech 2.0 conferences here. And uh, yeah, I want to share more information for you. So mainly we design and develop UC60, those kind of chipset and manufacture from TSMC. And we also give our engineering support to our customers, such as NASA or car OEMs, to implement those ideas to be realized. And these are our mass production adoption for smartphone or home application or robot arm tool change or joint. There are also many cables or connector, but when we move, it wear and tear. So we replaced by our chipset. So yeah, main two subject. So for AI space data center, especially now we need a docking. So um, previously, we didn't require those kind of high-speed data docking system because when we dock, like we have a communication cable inside of the satellite or inside of the space system. But when it comes to AI data center, there should be a backbone like that with the solar panel and radiator panel, and we should connect those kind of cabinet. Why that cabin, or it is also called cabinet, it should be docked to be connected with other cabinet. So there's a backbone inside, looks like a pillar, and there we need a not gigabit per second, not terabit per second, but petabit per second we need. And when we think about petabit per second, fiber optic cable inside of the data center, it supports around giga level or 0.8 level terabit per second, and we need 1,000 or 10K of them. But when we think about docking situation, the docking area is not enough. So we come up with the yeah, U.S. Space Agency. We come up with one idea. What if we not only this area but also like a interdigitate, if finger length is unlimited, then we will have an unlimited area of the connectivity. So we can have a theoretically unlimited speed we can make. So this kind of concept is on the proof of concept stage. So objective is enable ultra high bandwidth, low latency, serviceable data transfer between docked AI data center cabin and the backbone docking port. But current problem, I'm sorry, let me read through. So current problem is a fiber dense docking or copper dense docking, and undocking is complex and fragile or heavy and difficult to scale and service. So our solution is always gigabit per second, 60 gigahertz based contactless link, those kind of semiconductor chips. So to create modular, scalable, and serviceable docking connectivity without physical forcing in. Mm. Yeah, last but not least, so for self-driving car, we need high-speed data communication in order to rent our computing power to virtual data center or grid computing data center. Low latency like a gigabit ethernet and also high bandwidth is required to make efficiency uh, best. So the objective this kind of link is turn charging time into connected compute time by enabling deterministic high-speed data transfer for distributed AI compute, edge case data upload, and also model update. But current problem we have is when it comes to cellular or conventional wireless link are costly. Uh, how can I say? There's some kind of a KPI. Dollar per bit is a very high when it comes to cellular, like a 5G or 6G or Wi-Fi. But when we use our connectivity, it's a fixed price. So customer or car OEM doesn't require to have to pay per bit. So our solution is integrate our chipset into the charging port and also car port to provide always gigabit per second contactless data link for fast and lower latency to make money and also to have a safer self-driving. So today I'm here to share our idea that we are doing with our car OEMs and also US Space Agency. So yeah, here in Las Vegas, I also presented this kind of idea in the CES a couple of months ago, and there we found some US Space Agency and car OEM in US, so we have opportunity to work with them. So I love Las Vegas, and I hope you also enjoy Las Vegas time. And it'll be very happy if you could contact me and also talk about this kind of technology or business idea or partnership with us. So this kind of idea is maybe not familiar to you because it's an edge of the technology. So just before commercialization. So yeah, I love partnership and I hope you enjoy this slide. Thank you very much.